শিওর?
Mm-hmm. Sure, sure.
শিওর থাকবো। ওই লোকেরটা জানি কেডা?
The meeting has been recorded.
ইয়েস স্যার।
Okay. So in the last class we have derived the viscosity method. Now we will going to few terms regarding viscosity, that is different types of viscosity that we use different terms regarding viscosity
স্ক্রিন স্ক্রিন স্ক্রিন
such as relative viscosity, such as relative viscosity, specific viscosity, reduced viscosity, intrinsic viscosity. So we will go towards this. So just a minute. শানু কি কই, দুদিন ধরে ক্লাসে টাসে নাই?
নেট খারাপ খুব, কিছু শুনতেছে না
বৃষ্টি
এলিগা।
বৃষ্টি হইতেছে তো আমরা দিকে প্রচুর।
ও কালকে ও তো আসেনি। শিলচর নেটের কন্ডিশনটা আজকে খুব খারাপ। So definition of a few terms regarding viscosity. First one is such as relative viscosity. First one is relative viscosity. So a relative viscosity, that is an R, the eta R can be defined as eta by eta 0. And you know that what is eta and what is eta 0. Eta 0 is the viscosity of pure solvent. Is viscosity of pure solvent, and eta is the viscosity of solution that we have studied in our last class. Okay, eta is the viscosity of the pure, viscosity is the solution. So, so from equation 12 that we have derived yesterday, from equation 12, আমি ইকুয়েশনটা একবার লিখে রাখবো। From the equation আমি একবার লিখে রাখছি, যেটা কালকে বার করেছিলাম, যে ইটা ইকুয়ালস টু ইটা 0 প্লাস বি ইন্টু c2 প্লাস c ইন্টু c2 স্কয়ার প্লাস dot dot dot. This is equation 12 actually. In our previous discussion, this is equation 12. So equation 12, from equation 12 we get c2 plus c prime, just a minute, দুটোই বড় c মনে হচ্ছে, ক্যাপিটাল C, c2 square. So this is equation, I am continuing that, this is equation 13 and this is equation 14. Okay, I am continuing the number. So, and again for your information, the UPAC name of eta R name of eta r is the viscosity ratio. This is called the viscosity ratio. Okay. Now the second one. Now the second one, that is specific viscosity. Specific viscosity. So what is specific viscosity? So this is defined as we can say specific equals to n by n0 eta by eta 0 minus 1, and this is equation 15. Okay, this is equation 15. Now from equation 14, we get so we can write okay, so we can write it like this, as this is equation 16. So this is equation 16. Okay, next one, these are the very small types of discussion. 1 or 2 marks short question is possible for this. Reduced viscosity. Reduced viscosity. So what is reduced viscosity? So this is defined as we can say so 1 by C2 eta by eta 0 minus 1, and from definition we can say this is by C2. This is equation 17. From equation 16, we can get so this is 18 Okay, and here the U it also has a UPEC name. The UPEC name of viscosity, reduced viscosity, is viscosity number. It is viscosity number. So underline that. This kind of uh, definitions are very common in exam. What is viscosity ratio? What is viscosity number? Okay. Now, lastly, the intrinsic viscosity. The intrinsic viscosity. So this is actually this is defined as just a minute. So this is called intrinsic viscosity. That is, limit C2 tends to zero. Is the temperature is very is the concentration is very close to zero. Then reduced viscosity is called intrinsic viscosity. So from equation 18, that is from the above equation, from equation 18, from equation 18, we find that from equation 18 we find that intrinsic viscosity is actually equals to the coefficient B prime only. So I can say the value of intrinsic viscosity the value of intrinsic viscosity is is obtained by this statement is very important, obtained by determining the value determining value the value of the value of intercept of the graph of versus C2. So the intrinsic viscosity is often used as a value directly reflects the molecular property of the solute, and the UPAC name and the UPAC name of intrinsic viscosity is limiting viscosity number. It is called limiting viscosity number. So this is called limiting viscosity number. Okay. According to equation 11, I am also writing that what is equation 11. According to equation 11 is that there's the last equation that we have derived yesterday. So 1 plus, that is 2.5 C2 molar volume, molar partial volume I must say, by M2. Just a minute, it's just a comma there. Okay, M2 plus 4 C2 square V2M. Oh, not again. V2 PM by M2 square plus dot dot dot, that is eta of solvent. So this was equation 11, and uh, from equation 11, according to equation 11, the intrinsic viscosity 11, the intrinsic viscosity the intrinsic viscosity is given by, or as written as, whatever you can write. So C2 tends to 0, 1 by C2 n by n0 minus 1. So you can write it, the first term 2.52 যদি কেটে যায় C2 তাহলে V2 by M2, and this is 18. This is equation 19. This is equation 20. So this is equation 21. So this is the form of intrinsic viscosity. Okay. Now Here we can say that assuming the macromolecule to be globular, that is round shaped, its radius of gyration can be computed from an expression, that is we are using the volume of the sphere. The condition that we are considering, that assuming the macromolecule to be globular, its radius of gyration can be computed from the expression that we can say, that is intrinsic viscosity, that is 2.5 by m2, and V, the molar volume can be written, partial molar volume can be written then 4 by 3 pi r square by 3 by 2. This is equation 22. So this is about intrinsic viscosity. And another last type of intrinsic viscosity is there. One last kind of intrinsic viscosity is there, that is called inherent viscosity. That is called inherent viscosity. So this is defined as just a minute. Okay, then this is defined as inherent. Remember that it is inherent. So INH. So from equation 14, we get that is 1 by C2 ln C2 and this is equation 24. Now, from this equation, a graph between I and H, okay, and C2 also provide intrinsic viscosity, intrinsic viscosity when extrapolated to C2 tends to 0. That's why the IUPAC name that's why the IUPAC name of INH is called the logarithmic viscosity number. So these are the several type of viscosity that we can use, we actually deal with. So first of all, I'm going to the discussion again. First of all, it is relative viscosity, and relative viscosity can be determined as n by eta 0. That is, eta 0 is the viscosity of the pure solvent and eta is the viscosity of the solution. Hello? Hello? Phone? Wrong number. So from equation 13, from equation 12, we can write that relative viscosity equals to 1 plus b prime c2 and c prime c2 square. Just putting the value that we can get it. And relative relative viscosity is also known as viscosity ratio. Again, the specific viscosity, it is eta by eta 0 minus 1, and the specific viscosity, from specific viscosity and equation 14 we get specific viscosity equals to beta prime c2 plus c2 c prime c2 square, that is 16, equation 16. And what is reduced viscosity? It can be defined as 1 by c2 eta by eta 0 minus 1. So eta specific by c2, so reduced viscosity actually eta specific by c2, that is specific viscosity by concentration. So reduced viscosity is actually specific viscosity by concentration. And specific viscosity is also known as viscosity number. Specific viscosity is also known as viscosity number. Again, the intrinsic viscosity, this is the most important part of viscosity. That intrinsic viscosity is called, it actually reduced viscosity when C2 tends to 0. So go to the reduced viscosity when C2 tends to 0, that is eta by eta minus 1, that is eta Cp by C2, eta Sp by C2, that is specific viscosity by C2. So this is called intrinsic viscosity. When reduced viscosity, that the concentration is equals to 0. So if concentration is equals to 0, then eta intrinsic viscosity is equals to B prime. So it can be also written as written from the equation 11. And last one, the inherent viscosity. Inherent viscosity is equals to 1 by C2 log eta by eta 0. So it's called logarithmic viscosity by using equation 14. By simply using equation 14, we can say that 1 by C2 ln 1 by B prime C2 plus C prime C2 square. So from the curve we can calculate, from a straight line we can calculate the inherent viscosity, and it is also called logarithmic viscosity. Okay, so in our next class we will going to start Markov equation for determination of the mass of the polymeric substances, and then we'll go towards some processes again, such as sedimentation process for determination of the molar mass and all that. So today up to now, today up to this, we are going to discuss. Okay. Anyone, if anyone have to ask anything regarding the matter, then please ask me. And yeah, just a minute. Opurva,
Yes, sir.
ID,
Yes, sir.
Rajesh,
Yes, sir.
Tanmoy, nice. Bijoy, Anuki, Tahir আছে, অম্লান আছে,
Can I leave?
দীপজ্যোতি,
Sir,
হ্যাঁ,
can I leave?
ইউ ক্যান, দীপজ্যোতি, হরিপদ তো নাই, ওই দীপ্তনু, দীপ্তন তো আছে, হাম্পি,
Present, sir.
বিপ্লব, উদয় ভানু, নন্দিতা,
Yes, sir.
সাগরিকা,
Yes, sir.
কৌশিক, কৌশিক নাই, সঞ্জয়, সুমেন আছে, সুমেন আছে, রাজ, দীপাঙ্কি, অঙ্কুর, অঙ্কুর, বর্ণশ্রী, প্রচুর
Present,
অ্যাবসেন্ট,
sir.
প্রচুর অ্যাবসেন্ট তো, ঠিক আছে।